So great. So thank you. I'm Susan Clark, and Brandon Hensley is also on the line. I will speak first, but between two little talks here, we're going to tell you about the group that we have been leading together called the Pan-Experiment Galactic Science Group. We're still searching for the right shorthand. It's a bit of a mouthful. But this group came together not too long ago. We really started in earnest with meeting weekly at the beginning of 2021. And first, we want to just tell you a little bit about what this group is and why we felt the need to put it together and what we're up to. So our vision here is really to convene a group of people who are interested in using CMB experiments to study the astrophysics of the Milky Way. Our charge here is that all of us are participating in various CMB experiments, which are making incredibly sensitive multi-frequency observations of millimeter wavelength polarization. And that's incredibly useful for learning about the physics of our galaxy. And we really see our focus here as being galactic science as distinct from foregrounds. So obviously, depending on exactly your perspective, studying something like polarized dust emission in the Milky Way is also the study of foregrounds, and a physical understanding of that dust is obviously very relevant to things like component separation. But we see our angle as really being from about the physics of galactic emission. And then we are very open and happy and eager to work with other groups that are coming at this from a more component separated or foreground separated separation side, and interface basically with those groups, either groups like Cosmoglobe, of course, or working groups within constituent experiments that are doing their own thing. And so we see our scientific scope here as really being Milky Way astrophysics, and that includes a enormous host of different subfields that people are excited about. So we bring together people interested in star formation, in turbulence and interstellar magnetic fields, interested in dust physics, cosmic ray propagation, the multi-phase structure of the interstellar medium, which really requires a broad range of expertise, where what we can directly measure from CMB experiments is really just one particular part. And so separate from what we see as our particular scientific scope are the more specialized non-cosmological analyses that have been identified by various experiments. So a lot of us are excited about transient science with CMB experiments, but that really falls outside of our group for the most part. Likewise with solar system science, that's not really our focus. And if I can move to the next slide. Yeah. So our goal with convening this group is really to streamline collaboration. We see ourselves as sort of helpful scaffolding around whatever efforts might be happening within experiments already. And our role really is pooling expertise in order to develop and implement new analyses. So a lot of us work on multiple experiments, and a lot of us are have our attention scattered about to various things. And so we see ourselves as a place where people who often spend their time thinking very deeply about one particular experiment can come together with experts who work on other experiments and really facilitate the best possible galactic science. And so part of that can be, for example, making it easy to pull in members of the group as external collaborators on your experiments, some particular science that you might want to do with your particular experiment's data. But we do that strictly through whatever existing publication policy and collaboration policy already exists. So we see ourselves as being a helpful way to get the best people working on the best things, but we're not data sharing, and we're not complicating things for ourselves with MOUs and so forth. We really see ourselves as distinct from Cosmoglobe and maybe complementary in this way, that our focus is on sharing expertise and not necessarily data. And so as part of that, we are creating a shared toolbox, so GitHub, repo, et cetera. And we are developing software and analysis tools that will be public and open and shared among the community. And of course, a happy byproduct of convening a group like this is that we don't need to have an individual Galactic Science working group for every single experiment. We can perhaps reduce some of the telecom creep for some of us. So currently, the way that our membership works is essentially experiments join as affiliated experiments, and then anyone who is a member of that experiment is welcome to join our group. Currently, the experiments that are affiliated, which means basically the leadership has signed off on membership in our group, is ACT, BICEP-KEC, BLAST, CCAT Prime, CMBS4, Lightbird, SO, and SPT. And if you are a member of an experiment not on that list that would be interested in joining, absolutely get in touch. We're happy to add more experiments. And so once your experiment is affiliated, it's a simple Google form, which we can drop in the chat, and then you're in. And student is not themselves explicitly a member of one of the affiliated experiments. We are currently about 81 members strong, and part of our existence as a thanks, Brandon, as a pan experiment group is that we have our workspaces exist outside of the purview of any one experiment. So we have our own dedicated Slack channel, for example, where we organize a lot of this work. Brandon Hensley and I are co-organizing this group, and the project organization and paper authorship, we basically follow relevant publication policies if we're using data from any particular experiment. We have both a dedicated Slack and a GitHub repo, and we're working on a dedicated website, hoping to do half as well as Cosmoglobe has done on that front. That website is very beautiful. Okay. And there we go. Sorry, I don't know what's going on with my slides. So we are currently meeting weekly on Zoom, of course, and we're alternating between discussions of galactic emission modeling, which Brandon will tell you much more about, and hosting basically a Galactic Science journal club. So the idea here is that because our expertise is so scattered and there's so much to learn within the umbrella topic of galactic science, that this is a way to have targeted talks that let us learn something new about interesting work that is relevant to galactic science with CMB experiments, extremely broadly defined. So this basically means science relative to any of the science cases that we touch. And sometimes we also bring in people that are working on adjacent data sets that could be useful for joint analysis with CMB. We also want to use this time, to discuss particular experiments if there is a discussion that should happen within this group about what galactic science could be done with a particular experiment. It's a flexible format, and we're happy to use this as our members will find most helpful. So just to give you an idea of the sorts of things that we are learning about in this journal club, the 4 most recent talks, we had Yiling Guan talking about new ACT maps of the Galactic Center. Mernoush Tahani told us about mapping the 3D morphology of magnetic fields in molecular clouds with Faraday rotation data. Greg Green gave us the latest on 3D dust mapping. and Ioana Zelko talked about the correlation between the dust extinction and emissivity parameters. So this is really just a small sampling of what has been a very broad and wide-ranging talk series that we've put together. And I want to note here that exciting galactic science is really already underway with current experiments. Of course, we spend a lot of our time thinking about what's next, what are the new exciting data sets that will be coming down the pipeline in the next years. But groups like ACT, for example, have dedicated galactic science groups that are also already working on particular analyses with ACT data. And so you might recently have seen this paper come out led by Yilan Guan on microwave intensity and polarization maps of the galactic center. So this is the galactic center in 3 frequency channels of ACT in 3 different colors, red, green, and blue, in total intensity and in polarized intensity. You can dig into this paper to see what I think is a great example of some really unique galactic science that can be achieved with a CMB experiment, even though that was, of course, not the primary motivation for designing ACT. And so just to talk a little bit about what some of the very broad galactic science that we're discussing with these various CMB experiments is, I think sometimes we broadly partition this into science that is exciting because of the wavelength coverage of these experiments, and science that is exciting because of a large area of the sky being mapped or the angular resolution achieved and so forth. And part of being a pan-experiment galactic science group is all of these different experiments that we are part of have made different choices, primarily to achieve cosmological goals, but there are different ways to strategize your experiment to make the best measurement of R. And that necessarily means that we have different strengths from all of these different experiments for doing galactic science as well. There are different areas of parameter space that are better explored by one experiment or another. And so part of having this conversation ongoing is just really to identify what the unique or most exciting science is to do with any particular data set. Some of the things that are exciting on the side of spectral science are what's composition of interstellar dust, is the anomalous microwave emission polarized, how can we use synchrotron and dust emission to probe the 3-dimensional ISM? And on the map space side, some of the experiments that have high angular resolution are potentially very powerful for understanding questions like how gas and dust are coupled on small spatial scales, how magnetic fields influence the formation of molecular clouds and eventually of stars, and what really is the nature of MHD turbulence in the ISM. So these are all questions for which there are active communities working, where we think that CMB data, we know that CMB experiment data really has a role to play in furthering the observational landscape. So, for example, DustSED Science, one major open question that has not been answered satisfactorily yet is whether dust exists in 2 distinct flavors, whether there are dust grains that are primarily carbonaceous and some that are primarily silicate, or whether it's really just a mishmash where both of those components of dust exist on the same grain. And this has all sorts of implications for the formation of dust and how it's processed within interstellar medium of galaxies and so forth. So one particular test of this is whether the DustSED looks the same in total intensity as it does in polarized intensity, because one of these components is much more strongly polarized in the 2-component model than the other. Currently, measurements favor a one component model of dust, but there's a large class of two component models, and some of them are not rolled out. And so constraints are already being put essentially on the composition of dust. And this will get much better with upcoming data. Brandon Hensley led a very nice decadal white paper really laying out the case for this and specifically discussing the role for CMB experiments, if you want to check that out. There is also the question of AME, which we think often in terms of a foreground component, but it's still an open question whether AME should be polarized. They're basically upper limits, about 1%. And so the theorists are divided. So 1% or order 1% polarization fraction is expected by some. Other theorists say that it should be entirely negligible. And so we're really at the threshold of being able to figure this out. And the CMB experiments with channels around the peak of 30 gigahertz or so are really ideal for answering this question. And this point extends more broadly to other low frequency dust emission mechanisms. So magnetic dipole emission, for example. This is a place where the different choices of frequency bands of different experiments can be really powerful for narrowing in on these questions. Of course, we talk a lot about dust and synchrotron also as components of the foreground emission. But these are two very different probes of magnetic fields in the interstellar medium. And we know that dust and synchrotron polarization are correlated on large angular scales. It's really an open question to what extent that correlation extends to higher L. And because dust polarization, of course, is largely probing the neutral medium, it's probing the dust, and synchrotron polarization is probing what is sometimes called the relativistic medium, but the cosmic ray electrons. The coupling or lack of correlation between these two tracers is in principle a sensitive probe of the 3D structure of magnetic fields in the ISM. And so there is, I think, both observational and modeling work to be done there to better understand what we can learn from upcoming experiments. And very exciting on that front, of course, is the Pacify experiment, which I believe we will hear about later today, and you know, in combination with experiments like Gaia, to really use direct 3D distance information and starlight polarization to better understand 3D magnetic fields. I mentioned also that dust and gas, we know, are well mixed on large scales. There has been interest lately in the ISM community in understanding what it means physically for the turbulent ISM that diffuse neutral hydrogen emission is really organized into slender filamentary structures if you have high enough angular resolution data. And there's a question really of whether the dust polarization structure in diffuse regions of the ISM, where we have sort of the cleanest view on basic turbulence properties of the ISM, and whether that behaves similarly, or whether there is a scale at which the correlation that we see between filamentary structures in the dust and filamentary structures in the gas breaks down. And so there are different ways that you can quantify this problem, but the need is really for more sensitive, high angular resolution dust polarization data. And of course, that fits very nicely into what we're all doing here. Another point for high angular resolution experiments, especially those with large sky area coverage, is that really the problem of understanding star formation, one of the reasons that it is difficult is it's such a multi-scale process. You have to first form a molecular cloud out of the diffuse ISM, and then that molecular cloud has to fragment and eventually form cores, and eventually, on a much, much smaller scale, have regions that collapse and form stars. And it's been particularly difficult to study magnetic fields, the role of magnetic fields in this process, because making magnetic field measurements is difficult in general, but it's particularly difficult to do so with any sort of dynamic range in the observations. And so the real key to making progress here is to have high angular resolution observations that are sensitive enough to the range of scales that you can really probe from the scale of the molecular cloud down to at least the core scale, let's say. And you saw this figure in Shaul's presentation yesterday. But this is really a niche where some of the upcoming CMB experiments are really poised to make a dramatic advance in the number of molecular clouds for which we have this fidelity of observation, and also just how well resolved some of these molecular clouds are at these frequencies. Sorry, keep sticking. So we see ourselves as basically a galactic science meeting place. If you want to stay informed of what relevant data is available, so both within our experiments and also beyond for ancillary data or just exciting data beyond CMB experiments. If you want to discuss galactic emission physics and collaborate with people who are working at different wavelengths than you. If you want to take sort of a physics first approach to simulations and parametric models, which we'll hear more about from Brandon. If you want to really highlight how your particular experiment can broaden its science case to include unique galactic astrophysics, and if you want to interface with foreground mitigation efforts, this is the place for you. This is what we're up to with this group. And just fill out the form, or if you're not part of an affiliated experiment, but you want your experiment to join, please just drop Brandon and I a line, and we will get that figured out. And really what we want to bring to you today are your ideas for how we can best use this group. How can the existence of a pan-experiment galactic science group best interface with Cosmoglobe and best sort of serve the community needs at large? And part of this discussion, I think, is really what galactic science goals are you excited about, or what are things that we should all really have on our radar, or really be using the expertise of the people in this virtual room here to discuss more deeply. So thank you very much, and looking forward to discussion.